All right, so this is Physics 2212, Lab 2. My name is Max Minsky. As part of an introduction, the purpose is basically to determine the amount of excess charge on one piece of clear charge tape and to calculate the force of the electric field. And some of the primary physics ideas are that the model is distributed charge interactions with the tape. And we're also using a more complicated computational model to determine the net charge on the tapes. And we're calculating the number of excess electrons on the piece of tape. And we're also employing Newton's second law and the gravitational force, which are pictured to the right. We're also treating tape as a uniformly distributed charge across its length, like with a rod, with a uniformly distributed charge. And we're also assuming that the observation point is perpendicular to the charged tape and it's on the center line. So here's the electric field equation for charged rod at the midpoint. So this is also the electric force, which is Coulomb's law, which we are also employing, and also the fact that the electric force is equal to the charge times the external electric field. So the main results from the experiment, and this is mainly from lab one, but the charge tapes repelled each other and they were both positive signs. The net quantitative charge on each tape was to be 2.09 times 10 to the eighth negative coulombs, excuse me. And both pieces of tape were missing that many electrons. And this is the setup to our right of the first experiment. So the coding model that we used, basically each strip was of charge tape was used to model a point charge to see how things interact at a microscopic scale, right? And so many point charges on each one, as you can see. And some of the assumptions is that there are no errors since the tape of the same charge, just evenly distributed, and the tape will be modeled as many point charges. So this is the setup from last time. Um, it's pretty much, yeah, we're just breezing over it because I didn't do that this time. Um, this is the same thing. So we have the system and the surroundings, which is the two pieces of tape and then the rest of the room, and basically the tape talking about how we rip it off and remove the electrons. But um, right, so these are the mass and tape length and tape width and distance and the force of the gravity that I was talking about, and that's how I calculated our number. And now the number of electrons that we lost is all this stuff, and we figured out the electron ratio. So, um, really estimating uniformly distributed charge. How we're able to do that is we're able to set force of gravity equal to the electric force, and which we can see here is the Q times the electric field, which is that monstrous equation over there, which is the net rod electric field that we showed before. So here's the glow script model. We can see our constants in the top left, um, and just basically the bottom stuff below it creates like a line of charge, um, and the E field above that. So yeah, I mean you can see the code's pretty self-explanatory. After we do all that, we iterate and you know iterate so that we can get our desired number of electrons, and then we set them equal to each other and do our calculations. So some of the shortcomings of the model is that tape can't really be modeled as a charged rod because it's not a rod. Obviously, it's tape. And the charges on each tape were also likely not the same. So some of the error sources are that the scale only went into the thousandths place, so any smaller weight would have been rounded up. And I also eyeballed a ruler to measure the distance between the two tapes, so I only measured it in millimeters. And there were also unequal charges on the tape, so just really all around. So what if we had modeled each tape as a point charge, though, like in the past lab? Well, we saw that the point charge got us 2.09 times 10 to the negative eighth coulombs. But this time, the line charge, we got 1.73 times 10 to the negative third coulombs. So there's clearly a great magnitude and difference. Now, why are these estimates different? Well, the line charge model basically considers the length of the tape as well instead of just the charge. And the models take into account the fact that the charge is distributed along the tape and not just concentrated in one point. So there are many shortcomings of the model from last lab that we remedied in this lab. Anyway, that's about it. See ya.